All right, let's just jump right in. We've all been there, right? It's exam time, you flip the page, and bam, you're hit with this wall of statistics. Your job? To somehow turn all those numbers into a clear, meaningful conclusion. It can feel like you're a detective staring at a pile of clues with no idea how to even start. Well, don't worry. Today, we're going to crack that case wide open.
So, you see this? A table just jam-packed with means, p-values, confidence intervals, and the clock is ticking. What do? Panic? No way, not after this. We're going to give you a system, a toolkit that turns this intimidating block of data into a story that you can tell with total confidence.
So here's our game plan. First up, we're going to build your detective's toolkit, our 5-step framework. Then, we'll put it to the test with a case study on music's impact, see what happens when the clues go cold, and finally, and this is super important, we'll cover the 5 most common mistakes to avoid. By the end, you'll be ready to deliver an exam-ready verdict every single time.
Okay, every good detective needs their kit, right? Well, this is yours. This is your kit for cracking the data. Think of these 5 steps as your magnifying glass, your fingerprint kit, your notepad, the whole shebang. It's everything you need to systematically analyze the evidence and arrive at the right conclusion.
And here it is, your 5-step process. It's actually super simple when you break it down. First, we describe the descriptives. Basically, what's the general scene? Then we determine significance. Is this a real lead or not? Next, we interpret the confidence interval to see how precise our evidence really is. Then we evaluate the effect size to understand how big our finding is. And finally, we state our conclusion, tying it all together. So let's put this kit to work.
All right, time for our first case. The question is pretty simple. Does background music affect your concentration? So the researchers took 2 groups. One studied with music playing, the other studied in total silence. Then they measured how many problems each group solved correctly. The investigation begins now.
Okay, here is the evidence file. This is what we've got. We have the average scores for both groups, the difference between them, a confidence interval, a p-value, and something called Cohen's d. Right now, yeah, it's just a list of numbers. But believe me, we are about to make them talk.
So let's get started. Step 1. Describe the descriptives. Seriously, this is just about stating the obvious pattern you see right in front of you. Who solved more problems on average? The numbers are going to give us our very first clue.
And this is exactly how you'd say it. Notice how it's not just, oh, the silence group did better. A pro detective uses the specific numbers. You got to cite your evidence, right? So the silence group with a mean of 16.5 outperformed the music group with its mean of 14.2. That's our solid initial observation.
Okay, so we see a difference of about 2.3 problems. But here's the big question. Is that difference real and meaningful, or could it just be a fluke? Random chance. That is what statistical significance is all about. And looking at our table, we have 2 huge clues to figure this out. Can you spot them?
And here they are. What's so great is that this gives you 2 ways to confirm the exact same fact. First, look at the p-value, 0.004. That is way smaller than the standard cutoff of 0.05, so that's check number 1. Then, look at the 95% confidence interval. It runs from 0.8 up to 3.8. What number is missing? 0! It does not include 0, and that is check number 2. This is the golden rule, you guys. If the confidence interval for a difference doesn't contain 0, the result is statistically significant. Simple as that.
So here's the pro tip for your exam. Mention both pieces of evidence in your answer. This shows you really understand the why behind your conclusion. It's not just significant, it's significant because the p-value is low and the confidence interval doesn't cross 0. That's a top-tier answer.
Okay, so we know the result is significant. It's real. But how significant? That brings us to our next step, effect size. You see, statistical significance tells us there's likely a real effect, but effect size tells us if that effect is a tiny little tremor or a full-blown earthquake. It answers the question, okay, it's real, but is it important?
And in our case, the effect size, this thing called Cohen's d, is 0.89. Now, if you look at the benchmarks, that lands it squarely in the large category. So what does that mean? It means the difference between studying with music and in silence wasn't just a statistical blip, it was also practically meaningful. It had a substantial impact.
And now it's time to bring it all home. The final verdict. This is where we combine all our clues into one powerful statement. We state the relationship, background music negatively affects concentration. We back it up with our evidence, it's statistically significant with a p-value of 0.004. And we state the magnitude, it's a large effect, with a Cohen's d of 0.89. Boom, case closed. But what happens when the trail goes cold? When the evidence just isn't there? Let's look at another quick case. Does caffeine improve memory? Sometimes the most important conclusion a detective can make is that there just isn't enough evidence to go on. And guess what? Our 5-step toolkit works perfectly for that too.
Let's put the clues side by side. On the left, our music study, and on the right, this new caffeine case. And whoa, the evidence tells a completely different story. For the caffeine study, the p-value is huge, 0.65. The confidence interval goes from -2.1 all the way to +3.3, which means it definitely includes 0. And the effect size? A tiny, negligible 0.12. Every single clue is pointing in the opposite direction.
So our conclusion here is pretty clear, right? The result is not statistically significant. And again, we explain why. The p-value is way too high, and the confidence interval swallows 0 whole. This means the tiny difference they saw between the caffeine and placebo groups could easily just be random noise. There's no convincing evidence here. The trail's gone cold.
Okay, before you head out into the field, we have to talk about 5 rookie mistakes that can really get a detective into trouble. If you can avoid these, you'll be way ahead of the game.
First up, never just state a conclusion without your evidence. Don't just write, "The result is significant." That's not enough. You have to say why it's significant. Show your reasoning.
Second mistake, being vague. Specificity is your absolute best friend. Don't just say one group did worse. Use the actual numbers from the table to show how much worse.
And this one, oh man, this is a big one. When a result isn't significant, please do not say it proves there's no effect. That's not what it means. The correct interpretation is that we cannot conclude there is an effect. It's a subtle difference, I know, but it is absolutely crucial. Just remember, a lack of evidence is not the same as evidence of a lack.
So let's wrap this case up by recapping your essential toolkit, the one that's going to get you exam ready to deliver a confident verdict on any data you encounter.
Here it is one last time, your reliable 5-step method. Describe the pattern. Check for significance using both the p-value and confidence interval. Evaluate the practical importance with effect size, and then bring it all together in a clear, evidence-based conclusion. Just follow these steps, and I promise you can't go wrong.
So the next time you face that table of statistics, remember your training. You're not just a student anymore. You're a data detective. You have the tools. You have the method. Now you don't just see a block of numbers. You see the clues. You see the evidence. You see the story. You've got this.